So in this problem, we're asked to calculate the force between a hydrogen nucleus, which is a proton here, and an electron over here. And we're told that the distance between the hydrogen nucleus and the electron is equal to 120 picometers. And we're told that we should solve this using Coulomb's law, which is that the force is given by K Q1 Q2 over R squared. So all we need to do is substitute into this equation. So K, we're told, is 9 times 10 to the 9. Now Q1 and Q2 are the charges on the proton and the electron. And we know that protons and electrons have the same magnitude charge. It's opposite in sign, but it's the same magnitude. So we can call Q1 the proton's charge. So this is times 1.602 times 10 to the minus 19. And then for the electron, it's times 1.602 times 10 to the minus 19 as well. So obviously this is a negative charge. And then we divide by the distance squared. The distance is 120 picometers. So that's 120 times 10 to the minus 12 meters, and then we need to square that. And then we should just check that our units are working out. So the units for K are Newton meters squared per Coulomb squared. And then we've got coulombs times coulombs. And down here we've got meters squared. So we can see the meters squareds are cancelling each other out, and the coulomb squareds also cancel each other out, so we're left with newtons, which is the unit for force, as we'd expect. So now we just carefully put this into the calculator, and when we do that, we end up with 1.6 times 10 to the minus 8 newtons. Now I've written this here with just two significant figures, as in the question we were given K with just two significant figures. So that puts a limit on how many significant figures we should give the answer to. Now it didn't ask us if this was an attractive or a repulsive force, it just asked us for the magnitude. But in this case it is an attractive force, as we've got a positive charge and a negative charge, and unlike charges attract.